we're going to start with a really simple review today, and that review is going to build and build and build and hopefully help you understand what we're doing today. So let's do something easy. 2 plus 2 plus 2 is 6. Yeah, that's tough, right? So, is there a way to do that same calculation more efficiently? 2 times 3. 2 times 3. Is that the same as 2 to the third? No. 2 to the third is actually 8, and we're going to get to there in a minute. So 2 times 3 is also 6. Okay. Visually, I could have a pair of dots, and a pair of dots, and a pair of dots. And you see here, I have 3 sets of 2, which is 2 times 3, which is 6. Okay? Now, this is exactly the same thing as 3 plus 3, or I could turn 2 plus 2 plus 2 equals 6 into 6 equals 3 plus 3, or 2 times 3 is exactly the same thing as 3 times 2. Can you see 3 times 2 in this picture? I obviously see 2 times 3, 3 copies of 2. Do you see it the other way around? We could circle it this way, and now I have 2 copies of 3. So all of that is the same. What I'm getting at is addition can be combined and made more efficient using multiplication. Okay? So, can we make multiplication more efficient? For instance, if I had 2 times 2 times 2, that's 2 to the third. 2 to the third, which is 8. Well, exponents are just multiplication, and multiplication is really just addition, right? So we can turn addition into multiplication, and then we can turn multiplication into exponents. And oddly enough, this is just a continuation of what's already there. If I added another 2, so 2 plus 2 plus 2 plus 2, that is 8, right? So I could say I start with 2 and I double it, right? 2 times 2, this just means double. And I double it and get that. Well, if I bring in another 2, I just double it again. So addition can be turned into multiplication, which can be turned into exponents. Well, how does that help us? Well, what is x plus x? Let's think about it. Addition gets turned into multiplication, which gets turned into exponents. So x plus x turns an addition problem into a multiplication problem, which would be 2x. What about x times x? X squared. And this is a really common mistake in all levels of mathematics, is people get their addition and their multiplication mixed up. And really, it's all addition, right? Multiplication is just addition, and we can turn multiplication into exponents. So really, everything is addition. There are just different levels of addition. So we have the regular addition level, which can be turned into multiplication. And what if I had x of these? If I add x's together, that's a square that has x on one side and x on the other, and x times x is x squared. That's all we're doing. that make sense? This is, we have x times. So when you're adding things together, you turn them into a multiplication problem. When you multiply things together, you change the exponents. Sometimes you can add, and sometimes you can't. You can always multiply, but the rules are a little bit different. So if I had 4x minus 5x plus 2x minus 8x, can I put all those together? Why? What allows us to put them all together? They all have just an x to the first, and we call them like terms. There are 4 terms, and they all have the same variable and the same exponents. So 4 minus 5 is negative 1, plus 2 is 1, minus 8 is negative 7. Negative 7x. Why isn't it negative 7x squared, or x to the 4th? We're not multiplying. Adding changes the multiplication. Multiplication changes the exponents. So in order to add, the exponents already have to be the same, and they don't change. So if I had 6x minus 2y plus 3x minus 5y, can I put anything together? What can I put together? So 6x and 3x combine to be 9x. And then negative 2y and negative 5y would be negative 7y. Does that make sense? Okay, what about this? So I can put these together, but nothing else. Nothing else matches. Right? The variables and the exponents don't quite match up, so they're not like terms. You're not allowed to put them together. What does x and negative 5x make? Negative 4x squared. And 3x has no like term, so we just write it down. And then 2y doesn't have a like term, so we just write it down. Does that make sense? Okay, hopefully this is all review. And generally, we like to put things in alphabetical order, and we like to go from largest exponent to smallest exponent. Sometimes when there are multiple variables, that's kind of hard to do. But if yours is out of order, that's not a big deal. As long as you have the right terms and they're just mixed up as far as order goes, you'll be fine. All right, moving on to multiplication. What is 3x squared y multiplied by 4x to the third y squared? How do we do that? Any guesses? So we take care of the numbers first, and then the variables individually, and the exponents on the variables get added together. So the 3 and the 4 multiply to be 12. And then I have x there, and 3 of them here, a single y and a double y. And really, all I'm just doing is adding the number of x's together, and that becomes the exponent. So I have x to the 5th, because I have 5 of them multiplied together, and then y to the 3rd. If I lined it all up, it would be 3 times 4 is 12, x, 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 y, y, y. But since those are just long multiplications, we can make them more efficient by using exponents. Okay? So what if I had something like this? So this is just going to come along for the ride for now. And what do we call it when I multiply something into a binomial or trinomial, or it has a name? It's called distribution. You distribute the 5. The 5 is supposed to be multiplied by the whole thing, so you can multiply it by the whole thing on the outside, or you can multiply it by the individual parts. So 5 times x would be 5x, and 5 times negative 6 would be negative 30. Now what? The 2x and the 5x are now like terms, so 7x minus 30. Okay. Take a look at this. Okay, what if I had something like, what do you do there? So pull down the 6. And what is this really? It's a negative or a negative 1. So you can either think of it as you distribute a negative 1 or just distribute the negative. And what does a negative do? Actually, let's make that a negative. What does a negative do to everything on the inside? Just changes its sign. Whatever sign is there just gets changed. So negative 3x plus 1, which becomes negative 3x plus 7. Okay? And lastly, if I had 2 times x plus 3y and negative 4 times 4x minus 2y, I need to distribute both of these and then combine like terms. So that would give me 2x plus 6y. Everybody okay with that? When I distribute here, don't forget that there is a negative associated with it. It's not just 4, it's negative 4. So this would be negative 16x plus 8y. And then I combine like terms. Those two become negative 14x. And those two would become 14y. Anybody have any questions on that? Okay. Your assignment is the combined like terms page today. Good luck. Answer